Hi, I'd like to welcome you to West Hickman Creek in Lexington, Kentucky. The West Hickman Creek flows into Hickman Creek, which goes into the Kentucky River, so we're in the Kentucky River Basin. And my name's Melissa McAllister. I'm the chair of Watershed Watch in Kentucky, and this is my sampling buddy, Tricia Coakley. She's the chair of the Kentucky River Watershed Watch program that focuses specifically in this basin. And today we're going to go through the steps involved in a sampling outing, from selecting where you're going to sample, through collecting your information for your field form, and analyzing field chemistry, and then collecting a grab sample. Okay, I also want to go through all the items that you want to bring with you when you go to sample your site. We mentioned the field form, and it's helpful to have it on a clipboard with a pen just to make writing easier. I try to keep all my supplies in the white pan that's provided to you. These are the flip cards, the instructional flip cards that we give you at your training. We have the dissolved oxygen and the pH kit. There's actually two versions out there of the pH kit, so you'll have one or the other. We have a conductivity meter, a thermometer, the cup that goes with the conductivity meter where you take your measurement, a waste container to dump your chemicals in, and then also gloves for your sampling.
You're also going to take to the creek with you a jug of distilled water to rinse your equipment with after you've used it, so that you don't cross-contaminate when you go to another site or when you come back to the same site the next time. And also your sample bottles. Sometimes you'll only have one sample bottle for E. coli. For other events, you might have different types of sample bottles to collect for metals or nutrients as well. And then you'll want to have a cooler with wet ice ready to receive your sample when you pull it from the creek.
Okay, first I want to talk a little bit about how you decide where you're going to be taking your sample. We like to find a spot in the stream where we have good flow, such as over here, where you can dip your container to about mid-depth without it touching the stream bottom, because if you disturb the sediments, that can contaminate your sample. So this over here, and also it's better to have moving water as opposed to a pool or standing water when you're taking your sample.
Okay, so it looks like, Melissa, the first field observation we have to take is flow rate.
Okay.
And we have a scale from 0 to 5, and 0 being dry, 1 ponded, 2 is low, 3 is normal, 4 is bank full, and 5 is flood. How should we assess this stream and decide which of the categories it fits?
It's not dry and it's not flooded.
No,
I know that. And it's not ponded because there's continuous flow.
Yeah, it's definitely not a flood. Bank full or normal or low is where we're at.
So this gets a little easier the more times you go to the creek and become familiar with it. But I would say that this is pretty much normal flow. It's not going over the banks or even close, so I wouldn't say it's bank full. So what's that, a 3?
Yeah, a 3 is normal.
Okay.
All right, let's call it a 3.
Okay, you want to record that?
Okay, so the next field observation we have to collect is the 48-hour rainfall, and that's on a scale from 0 to greater than 1.5 inches.
Right.
How do we find that information?
Okay, so if we know it hasn't rained in the past 2 days, it's easy. We can just note 0. But if we think we've had some rain but we're not sure how much, you can look on Kentucky Mesonet. It's a website that has rainfall data for every county in the state, and check it for the past 48 hours and record that. Or if you have a rain gauge in your yard and you're close to your stream site, you could check that.
Okay, so I could enter this data when I get back to someplace I have an internet connection. I don't have to enter it while I'm here at the creek.
Right.
Okay. So now we need to measure turbidity, and that is an estimated measurement, it says, on a scale of 0 to 3, with 0 being clear and 3 being turbid. How do we do that?
Okay, so we want to look at the water and see how easily we can see through it, because turbidity is a indicator of like the suspended sediment or dirt or other particles in the water, and it can make it cloudy and difficult to see the bottom. If it's really turbid, so the highest rating, it will look like chocolate milk. And Usually you'll see that after a really heavy rainfall washes dirt in, maybe from the eroding stream banks or from disturbed land next to the stream. So what do we think about this creek today?
I think this doesn't look perfectly clear, but it's not too bad. I think maybe a 1.
Yeah, I would agree with that.
Yeah. I think it looks more turbid where we just walked, though. I think we have to be careful to look at this where we didn't walk yet.
Right.
Okay, I'm going to call it a 1.
Okay. All right, so it looks that all that's left here is general comments. So the general comments field is just kind of general observations about the water and the surroundings itself, like if there's an odor or if there's like floating scum or foam, maybe if there's any wildlife you get to observe while you're out there, any creatures in the water, maybe any changes in land use in the area that might affect your water quality results. Okay, now we get to start with the water chemistry. So we're going to start with the easiest one. Let's do the temperature. And so, Tricia, if you could take the thermometer out of the little holder and you want to submerge it into the water about mid-depth of the stream and wait until it stabilizes. Okay, so what did you find?
So it's 15 degrees Celsius.
Yes, so we need to record it in Celsius. All right, next we're going to do the conductivity measurement. Okay, let's get our conductivity reading. First I'm going to turn the meter on, and I did calibrate this last night in the solution that we have. Okay, it's zeroed out, and so I'm going to put it in the sample and stir it around a little bit and let it settle on. Has it stabilized?
Yeah.
Yeah. So what's that reading look like?
300 microsiemens.
So let's record that. All right. So next we're going to test pH, and we're going to use this little tube to get 5 milliliters of water. There we go. Exactly 5 milliliters. And then if you could add 10 drops of the reagent. 1, 2, 3. Okay. And then cap it and mix it. And then use this comparator to see which color it matches. And what do you think? I think it's actually closer to 8.
It is closer to 8.
So maybe 7.75.
Yeah.
Okay. Okay, so now let's dump that into our waste container and move on to the dissolved oxygen. I'll rinse this out when we get back to the car. Okay, so now we're going to do dissolved oxygen, Tricia. I'm going to get the water sample first. I'm going to uncap this underwater so I don't get any oxygen from the air. And hold it upright and let it fill. I can hear it. And I'm going to recap it underwater. Oh, I've still got air in there, so I got to do it again. Great. No bubbles. Okay, so no air bubbles in there, so we're ready to do our measurement. So 8 drops. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Number 2 bottle, which is
8 drops of alkaline iodide azide. Ooh, it turned a color. Yeah, the precipitate is getting larger as it settles too. Look, Melissa, I think it's settled past the shoulder.
Yep.
Now we can proceed. Go to the next card and add 8 drops of sulfuric acid.
okay. Number 3, and it has the red lid because it's acid, so we don't want to get this on our skin.
And then it says to cap and mix it again until the precipitate dissolves.
All right, so what's next?
Okay, now it says our next step is to fill the test tube until the bottom of the meniscus is aligned with the 20 milliliter line, and then cap it.
Okay.
Wanna?
Okay.
Now it says we're gonna fill the syringe, and they call it a titrator, with sodium thiosulfate to the 0 line.
Okay.
And then we're going to add drops while swirling after each drop until the sample turns a pale yellow color.
You think that's pale enough, or keep going?
I keep going.
Okay.
Let's get in there. Yeah, that looks
Okay.
good.
I think that's good.
Okay. And then it says we're going to add 8 drops. I'll hold that for you. 8
Now we-
drops of the starch indicator.
Okay.
Now you're going to mix that and then continue with the titration.
Okay, so I just want to keep dropping and swirling until it turns clear, right?
Clear. Yeah, colorless.
It will just be like magic, won't it?
It's getting lighter.
Come on.
Oh, it tried to go clear. Oh, it's getting close. So
Okay.
now we're supposed to read what the measurement on the syringe is.
So I want to look at where that green plunger is, where the bottom of it is, and each of those lines between the numbers is 0.2, so I think this one is at maybe 8.4. What do you think?
Yeah, 8.4.
Okay. All right, so let's dispose of all this in our waste containers.
And you said you're going to rinse everything when we get back to the car, right?
Yeah.
Okay, so I guess let's collect the grab sample now. They sent us 2 bottles. I think this one it said was for E. coli, and that one's for metals analysis.
Okay.
So the E. coli bottle came sealed because it's sterile, so I'm going to remove that
Here,
seal.
okay, take that.
And it has a little pill in the bottle. It looks like an aspirin. The last time we received sample bottles, it just had white powder inside of the bottle. This
What's
time
that
it's a
for?
pill. It's sodium thiosulfate. It's supposed to tie up any residual chlorine that's in the creek so that it doesn't limit our bacterial analysis.
Gotcha. So we don't want that to come out when you take it.
Right. Okay. Yeah. Okay, so I'm going to collect the sample and make sure that I don't collect it running across my boots. So I'm going to walk into the stream and go up without falling down. And I'm going to sample with the water flowing towards me.
Make sure you don't touch the bottom with it too, right?
Yeah, I'm going to go into the middle of the stream water, not the bottom. And I'm going to make sure that the pill doesn't fall out. And then cap it.
Is there a little space in it?
Left a little bit of head space, yeah. So that they can shake it at the lab. Okay, and then this one the same way for the metals.
Except you pre-rinse that one 3 times, remember?
Oh, 3 times.
Yeah, and you pour it downstream after you pre-rinse.
So I'm pouring it behind me. Sample in front of me.
Maybe rinse the cap too. That's fine. Thanks for joining us on our sampling outing today. Hopefully you can find a great sampling buddy like I had to help you, and it also helps with understanding your results afterward. You can talk about them and try to make sense of them, and maybe help educate others and teach others in your community about what you're finding in your creek. If you want to find out more information about Watershed Watch, we have a website at www.ky.org, and we hope to see you out in the creek soon.